Hello, this is Jonathan Greiner from Basin Safety Consulting and Training. This month, May 2021, we're going to be covering fire safety and extinguisher use, hot weather work, and heat illness prevention. As far as fire safety goes, our agenda is talking a little bit about fire science, how it works, fire classification and prevention, hot work permits and fire watch requirements, NFPA symbols, site-specific safety, all the training requirements required for fire safety and extinguisher use, fire extinguishers themselves, and then lastly, emergency response. So the four elements of a fire, and kind of delving into the fire science side of the house, are fuel, oxygen, heat, and chemical chain reaction. These used to be called the fire triangle, but now in recent years has been dubbed the fire tetrahedron because it's a three-dimensional triangle. So if you remove any of these one elements from a fire, the fire will be extinguished. So all of our fire extinguishers are designed to remove one or more of these different elements. Fuel is really any combustible material, solid, liquid, or gas, something that can ignite. Oxygen, fire typically needs only 16% oxygen to ignite, which obviously our ambient atmosphere has that, but less oxygen than that, there will be no fire. Oxygen itself can be flammable at certain levels as well. Heat is another necessary element of a fire. And every, different types of gases have different amounts of heat necessary to auto-ignite them. So some of them are in the just 70-degree range, your average summer or spring day. In those cases, you want to consult your SDS to determine, what's the auto-ignition temperature of this chemical, and that'll give you a good idea of how to store it and where to store it. And lastly is the chemical chain reaction. This is essentially having enough exothermic energy to change the liquid to a gas and ignitable gas mixture, a solid to a gas and ignitable gas mixture, etc. So once again, all of our fire extinguishers and prevention methods are designed to remove one of these elements from the fire. So there are 5 different fire classifications. You have A, B, C, D, and then jumps to K. I've given a quick little cheat sheet, if you will, about how to determine which is which. A Class A fire is any fire that when burned, the material turns to ash. And that's kind of an easy way to remember, what a Class A fire is. So this is paper, wood, cloth, rubber, some plastics, and even some rubbers. Some of them are considered a Class B fire. And the reason for that is anything that when melted or heated has a boiling point would be a Class B fire. So liquids such as gasoline, kerosene, paint, gas, propane, methane, really any sort of gas that could ignite. Now, I don't recommend this, but if you take gasoline and put it into a pot onto a stove or a range and turn that sucker on high, you will get boiled gasoline. Highly don't recommend this just from what your house is going to smell like afterwards, and not to mention the safety concerns, but these gases in their liquid form, even things like methanol and methane, etc., in liquid form, they do have a boiling point. So Class B fire, anything that boils. Class C fire is anything that has a current or a charge. So if it's electrical, it's in the Class C range. Now, Class C fires are pretty easy to detect, and we'll talk about that later, but if it has a current or a charge, it's a Class C fire. Class D is anything that dents. So titanium, magnesium, potassium, sodium, etc. Metal fires are considered Class D fires, and they require extremely specific elements to remove the ignition source or remove the oxygen from the fire. Same thing with the Class K or a kitchen fire. Grease fires take a little bit extra, vegetable fats take a little bit extra material in order to not only put them out, but also cool them off so they don't reignite. So preventing a Class A fire is something we do every day. We don't store things on top of a heater. If you have kids, this is something you probably have to remind them of in the wintertime. Paper, etc. is stored separate from any sort of heat source. And that's typically how we prevent a Class A fire. Just keep combustible materials away from a potential heat source. Don't throw your cigarette butts in the trash, etc. Class B fires, typically when there's an ignition with a Class B fire, it's during some sort of refueling service or task. So the way, we want to make sure that we're preventing, we're using the right type of fuel pump, that they're grounded so that static electricity doesn't build up and cause ignition. Flammable liquid storage is another issue, so making sure that they're in a storage cabinet designed to store those chemicals and prevent vapors, etc., from escaping, and always storing in a well-ventilated area. Also, you want to make sure that if you are storing flammable chemicals and materials, that you recognize the quantity maximum. So there are 3 different types of flammable liquids, and depending on what type of flammable liquid, there's a maximum amount that you can store inside of a storage or warehouse or a storage facility. So make sure that you know that. The best way to check that is on the SDS to determine what type, and then consult OSHA's guidebook on how many gallons of that chemical you can store. There's also a requirement for those 2 different types being stored next to each other or near each other, and they always want to have a barrier of some sort. Once again, you don't want multiple different types of flammable chemicals, vapors mixing together, creates a real hazard. So our next type of fire, Class C, as I mentioned, is something that holds a charge or a current, electrical fire. The telltale prevention or the telltale sign that there's a problem and prevention methodology is if you smell, burnt rubber, that acrid odor, you want to investigate. Is there something wrong in this room? Is there a wire that's getting old or getting burnt out? Extension cords and power strips, they are typically sold and created by the lowest bidder. Therefore, they're not always the highest quality material. Now, they are inspected and stamped for approval, but that doesn't mean that they last forever. So you definitely want to make sure that you're keeping an eye on your extension cords, that there's no cuts to them and frays. Things like that can ultimately lead to a fire if the wrong piece of material also gets put onto those extension cords. And also, utility lights should have some sort of wire guard over them. You essentially want to protect electrical cords and inspect electrical cords. That's your best way to prevent fires. Class D, again, metal fires. Knowledge of the properties of the metals is extremely important. Is this a material that can ignite easily, and in what conditions, and then prevent those conditions from occurring. Also, having the right extinguisher media and safe distances from other things, so that if a fire does happen, then it doesn't catch on to other things and spread. So there used to be a car, the Volkswagen Beetle actually had a magnesium block engine, a large amount of magnesium inside. And as most of you know, the engine was in the back of the vehicle and not in the front, in the boot, as they'd say in England. And when vehicles would rear end these bad boys, they would catch fire. The magnesium would catch fire, ignite, and that car would be toast. So ultimately they remove that because of safety concerns. But magnesium is really no joke. So you can't put it out with an ABC extinguisher that most of us have. Typically the solution to that instance is just run away and get as far away as you can, as fast as you can. Class K fires, kitchen fires, you'll see these extinguishers if you ever look behind the corner at a restaurant. They're the big kind of aluminum ones or steel. And Class K fires are cooking oils, etc. And what this extinguisher medium does is it not only extinguishes the fire by removing the oxygen, it's kind of a wet chemical, it also prevents reignition by cooling underneath it. So it's a really saturating type of solution. So that's the best way to describe the Class K fire extinguisher. The best way to prevent these types of fires is obviously cleaning up after grease and oil get around, not storing oily or greasy rags altogether, because once again, depending on the ignition temperature, sometimes a hot room, the back of a pickup truck, even with your Class B materials like gasoline, methanol, oil, etc., can ignite if they hit a certain temperature. Getting into hot work permits and what they are. So definitely, the definition of hot work is any hot work that's creating an ignition source within 35 feet of a flammable source. So of a wellhead, of a tank, of a treater, of gasoline storage, anything of that, propane storage, anything of that nature. Now sometimes hot work does need to be done within 35 feet. In those instances, and sometimes it's 50 feet depending on the customer you're working for, in those instances, a hot work permit needs to be completed prior to performing work. So the NFPA standard for that essentially says any combustibles need to be relocated at minimum 35 feet from the work area if it has to be done. And even in that instance, we need to make sure that there's a hot work permit. So brazing, cutting, grinding, soldering, thawing pipe, torch applied roofing, welding, smoking wouldn't be considered hot work, but any sort of flammable source within 35 feet needs to, requires a hot work permit. Some customers require a hot work permit for any hot work performed on site, regardless of distance. So make sure you connect and contact the specific customer you're working with and determine what their requirements are for a hot work permit. So I've included a couple examples and kind of blow-ups of a hot work permit, what it looks like, what all needs to be, on that permit. So typically we have customer representatives being contacted and making sure that that's documented. The permit needs to be, followed, and essentially, typically, the permit's going to look something like this or have these sorts of instructions. So where you're doing the work, there's going to be a precautions checklist. Making sure that everything's protected. There's welding blankets down if necessary. You have adequate ventilation. Sparks are being caught or prevented from, just kind of blowing wherever. We've eliminated the gas source. We've closed a valve. We've locked it out. We've put a cap on, a blind, whatever we need to do to prevent a flammable material from, being exposed to the atmosphere, etc. And then it kind of goes down the lines where you're working. Obviously, even working inside of a house, if you're doing hot work and near a wall that's open and you get some sparks down into the wall, you can have some issues depending on, age of the house, the type of lumber they use. There's a lot of different factors there. So hot work permits can be extremely helpful, just giving you that extra couple steps to make sure that you're preventing possible injury or issues. So fire watch requirements. A fire watch typically is going to go hand in hand with a hot work permit. This is somebody who stays behind watches the work first of all, and then stays behind after work's completed for at least 30 minutes to make sure that sparks aren't igniting somewhere, smoldering, that any sort of issues or concerns are being handled, and that's what a fire watch does. So the expectations that, once again, at least 30 minutes after completing the work, he's there to extinguish any possible fires. And we give that 30-minute window just as a buffer to make sure that there's no issues. So if you are required to do fire watch duty, obviously keeping a diligent watch for fires, preventing fire ignition sources, talking to the person performing hot work if a new hazard enters the area, being the person to call 911 or the fire department if there is a fire, and obviously, once again, being on standby to extinguish a fire if you do detect one. So they need a specific PPE, basically all your basics you're going to need on a location, with addition of some respiratory protection equipment and having FR gear, maybe even potentially NFP level 4. There's different levels of fire protection, FR clothing. You probably in that instance are going to want to spend a little bit more money on the higher protective equipment. So there was a short video there. I went ahead and skipped just in the interest of time, but essentially went over the hot work requirements and fire watch requirements. So NFPA symbols, you've seen these. There's 4 different symbols. The one on the far left is for health. The one in the top center is for fire or flammability. The one on the right is for reactivity, or if there's any radiation. And then on the one in the bottom is for any special precautions. So in this case, this is the NFPA symbol for crude oil. As we can see, crude oil has a level 3, which is a higher risk, meaning that it is more flammable. And that's determined by temperature of ignition. So what our LEL requirements are and what temperature it ignites at, that's where you get those higher or lower numbers. So getting to a well site and understanding where does ignition happen on a well site. We've all seen flares. This is an example of a Steffes flare stack. This is where excess gas that isn't being sold or used in the well is being sent to ignite for waste management. So there's definitely going to be a fire there, and obviously we want to prevent flammable materials from being within a short distance of the Steffes flare stack. This is a lower stack. As you can see, it's about 8 feet high. Sometimes they'll be 12, 15, 20, 30 feet high, depending on how much gas is being fed to that flare and where they feel it's safe to ignite at. So well specific inside, this is just kind of the breakdown of a horizontal separator on the left and a vertical treater on the right. Horizontal separator and a treater inside are going to look relatively the same, a lot of the same parts and components, but at every one of these points that we have kind of highlighted here, there's a possibility of a leak or a release. In that case, you want to make sure you have your 4-gas monitor on with the LEL sensor working. This is going to detect that leak and give you, an idea that, hey, something's wrong. In that instance, depending on your company's SOPs, you may be responsible to leave, you may be responsible to open a window. It just depends on, what the requirements are. On the right here, you see the back side of a treater, and horizontal separators have some version of this as well, typically a stack, fire tube, and a burner. This is another place where ignition is intentionally occurring. So these burners are used to keep the treaters or the separators at a certain temperature. Sometimes almost always they're on the freshwater tanks as well. This is where some well gas is being fed there at a low pressure, which is ignited and keeps the vessel at a certain temperature. So once again, we have ignition, intentional ignition, and that can be a source of flammable materials being ignited. So burner stacks are also going to be hot, just something to be aware of. So even the heat from the burner stack with certain gases present could potentially ignite. So that's why leaks, etc., being detected are important. Also, a wellhead, there can be leaks there, which could potentially cause ignition. That's why we want to make sure we keep a 35 to 50 foot radius from all these different types of equipment, tanks as well, when we're performing hot work. So training, true fire extinguisher training, and for all of you on in this class right now, we are not obviously doing hands-on fire extinguisher training, but you must, if you are expected to use a fire extinguisher, you must be trained in its use and actually have hands-on experience. So we do have a hands-on training rig. We've got an electronic one, which is pretty cool. You can simulate different types of fires, and we have a physical one where we use diesel and gasoline mixture and put that out with fire extinguishers. So it really just depends on what type you want to do, but if that's something you want to get scheduled, just get me with your safety person, and we'll definitely get you scheduled for that. Inspecting fire extinguishers, they are required to be inspected, pressure tested, the inside looked at, etc. Each one's going to have an annual certification where it's weighed, make sure that there's no powder or material that's caked in the bottom. Also that we do a function check of the handle and the hose, make sure it's not plugged or blocked or anything. And then every 5 or 6 years, depending on the type of extinguishers, it goes through the more thorough inspection. The other thing we're going to be looking at is the pin, make sure that it's in place, tamper seals aren't messed with, and then if it has been used, no problem. We just go ahead and refill it, test it, weigh it, make sure it's good to go. So different types of extinguishers they have out there. Typically you have a water extinguisher for type A fires. That's considered a class A fire extinguisher. Good for, once again, paper, plastics, wood, cloth, etc. Type B is typically going to be some version of foam or powder. depending on if you just want a specific Class B fire extinguisher. That one's usually going to be foam. Now, most of us work with Class A, B, C extinguishers, and that's a powder extinguisher. So that's typically going to prevent ignition, cut off the source of oxygen, and also, remove the possibility of chemical reaction. Carbon dioxide removes the oxygen from the fire. So that's complete, hey, we're displacing oxygen. Once it gets below that 16% mark, the fire will extinguish. And lastly, we have wet chemical, and that's typically used, as I mentioned before, in Class K fires and kitchens, etc. So I kind of went through this pretty basic. That's essentially what they're designed to do. This has given us just a little bit more information about each different types of fire. Now, they used to use something called hydrogen tetrachloride, which was also an oxygen displacer, but it did far too well of a job. It was in a liquid that would be suspended in the air inside of something that looked like a light bulb. They also had bombs of these, like almost grenade-looking things. And this liquid, once the wax seal melted or you threw the thing, the glass would break on the ground and the liquid would be released, which quickly turned to gas in the presence of heat. And once that gas was released, oxygen would be gone. But if you were anywhere within the vicinity, the oxygen you need to breathe would also be gone, and you would typically pass out. So after many instances of issues becoming far worse because of hydrogen tetrachloride, they went ahead and got rid of it. So if you have to fight a fire, and you'll obviously we'll go a lot more in depth with this with the hands-on fire extinguisher use, you want to make sure to remember the acronym PASS. Pull the pin right out of the side of the handle, aim the fire extinguisher hose, make sure that that's released from the clip on the side. Then you're going to squeeze that handle down, and it takes a good grip to do so, and then sweep side to side at the base of the fire. Again, from the fire tetrahedron that we went over earlier, removing the possibility of the chemical changing from one phase to another, as well as oxygen. You want to make sure that you're actually hitting the flammable material, not just the flames. The flames are, after the gas has already been released and ignited. That's essentially the end of the fire's life, if you will, of the gas's life when you see it on fire. But you need to really get down at the base, or the essentially where the material, the combustible material is. So a few tips really quick on how to use a fire extinguisher, when to use a fire extinguisher. There's a stage in fires that we call the incipient stage. That stage is essentially when the fire is first forming. So when that material is changing, it's formed from liquid to vapor and then igniting, or solid to vapor and then igniting. Right away, that's called the incipient phase, the early stage. That's the best place, obviously, to catch a fire with an extinguisher, because really you're preventing it before lots of material has been ignited. It needs to be listed and labeled by an independent company. Again, Basin Safety has our own fire safety service division. We've got a van that goes out to the field, inspects extinguishers in the field. We do standpipes and fire sprinkler systems, alarm systems, and everything. So this is something we're extremely familiar with and do on a consistent basis. Those need to be labeled, tagged, certified, and within date. So if you see one that's out of date, definitely let us know, and we can come and take care of you. So the other thing about fighting a fire is, even if it's in the incipient stage, before we attempt fighting a fire, we want to let everybody know. We want there to be communication so that other people can get out in case your attempts fail. If you're, let's say you try, but then the fire gets out of control and everybody's still in the building. Now we're in a much worse position because the fire is more advanced without everybody being to safety. So we want to make sure that we get everyone out and safe first. So sound the alarm, have the front desk call, yell, scream, whatever we got to do to get everybody going. Now at that point, and we'll talk about this a little bit later, but we want to make sure that everybody knows and understands the evacuation plan, where to go, and what to do when you get there. Again, everyone needs to know how to use a fire extinguisher, otherwise it can actually put that person at more risk if they're not familiar with the extinguisher and how to use it. And you should be trained on all the different types of fire extinguishers you have. So if you have 3 different types of extinguishers, you should practice on all 3 different types. Different types of fires need to be fought differently. Same principle, but different methods. So the way that we actually push back the fire and extinguish it is going to look different depending on the type of fire. So we already talked about pull, aim, squeeze, and sweep. Good to go. If you have the slightest doubt of whether or not you can get out, you don't want to fight the fire. Exit is priority. Human life is priority. Companies have insurance policies on equipment, materials, well sites, tanks, treaters, separators. There's insurance. So the loss of human life, there may be an insurance policy, but you can't just replace it like you can a piece of equipment. So get out. Remember to close the door behind you if everyone else is out of there. And that will prevent the fire from spreading faster. Again, your safety comes first. Exit is first. Communication is first. Before we do any sort of fire extinguishing, we want to make sure everybody is knowledgeable about the fire and is on their way out before we start trying to fight it. So being prepared for a fire emergency, we want to make sure fire alarms are working properly. Everyone understands the evacuation plan. Knowing where 2 exits are located, so where you go depending on a fire. Right now I'm in a training room, so I have an exit to the left out the shop, or to the right out the front of the store, or the back of the store, pretty much equal distance from where I'm at right now. Making sure nothing's ever blocking fire extinguishers. They need to be at least 3 feet off the floor. They can't be stored on the ground unless you're outside and they're away from walls and materials. There should be a sign there, and then also you don't want to put the boxes that came in from UPS yesterday in front of the extinguishers, tools, equipment, carts, etc. All that needs to be away so you can reach that extinguisher in the event of an incident. So you want to know the sound of your building alarm, or how an alarm or communication system is going to work with your company. Emergency numbers should be out and about. Typically 911 is the easy one, but there's other numbers other than 911 that your company may require you to call. Make sure you know them and you have access to them. And then also what to do if the fire alarm happens. Are you supposed to call 911? Are you supposed to check on everybody? What's your role in the event of a fire? Exit routes, a couple different things about them. Again, plans need to be posted. People need to know how to get to their closest route. Exit paths need to be clear of obstructions. So there's a lot of aisle requirements, and I'm sure all of us have gotten in trouble at one time or another for breaking the fire code in a restaurant or somewhere. There needs to be a certain width. It's 28 inches of clear path towards a fire exit. And also, once you get outside of a building, you want to make sure that there's nothing right there that's going to prevent you from access to the muster point. Cars can be a problem. Materials being stored in the wrong place. I've seen in certain instances propane tanks being right in the path of the fire exit out of the building towards the muster point. Not a great look, so we definitely want to make sure that not only is our exit out of the building safe, but the continued exit to the muster point is also safe. So again, kind of went over this. I'll just do a quick touch. There's 4 elements to a fire. It's called the fire tetrahedron: fuel, oxygen, heat, and chemical reaction. 5 classes of fire: A, ash; B, boiling point; C, charge or current; D, dense; and K, kitchen fire. So those are our 5 classes of fire. Hot work permits are required for any work being done close to ignition source. Fire watch is a person that stays after the hot work's completed to verify that there is no fire for at least 30 minutes. We use the pass method when using an extinguisher. That's pull the pin, aim at the fire, squeeze the handle, and sweep side to side. Lastly, being prepared is important. A lot of you are going to remember from elementary school what you were supposed to do and what it looked like when there was a drill. Hey, there's a fire alarm drill. Everybody gets up, leave your backpack, get behind Susie, walk out to the playground or the street, whatever. A lot of you can remember that. And the reason for that is drills do have a way of sticking in our memory. So your company doing drills is also extremely important. So if you haven't done a drill in the last year, you can talk to your manager, or if you are a supervisor or manager, get everyone together. Just say, hey guys, we're going to do a drill right now. There's a fire. What are we going to do? Get everyone outside, take a head count, make sure everyone's following the proper procedure. All right, hot weather work and heat illness prevention. 2 of my favorite topics. Maybe I'm telling the truth, maybe I'm not. You'll never know. Heat stroke is one of the big issues for hot weather work. So there's a few different symptoms: rapid heartbeat, no sweating or hot red skin, dizziness and headache. You're starting to feel that way. It may not just be the hangover from last night, or that may be contributing to it. Definitely you want to make sure when it's hot outside, any of these symptoms are accounted for and then dealt with. Unconsciousness, vomiting are also 2 major symptoms of heat stroke. So prevention, as I mentioned, alcohol can cause The thinning of your blood prevents water from moving through your system quickly and keeping you hydrated, so you want to make sure that you're well hydrated. Thick clothes can cause a problem. As I mentioned earlier, we have thicker FR, NFPA 4. There's also thinner FR, which I highly recommend for summer operations. It's an NFPA 1. You'll see it, or hazard class 1. You'll see it on the FR clothing, and I recommend that. Typically a lot more breathable. Outdoor time needs to be limited, a lot more frequent breaks, wearing the right protection, sunblock, etc. Drinking enough water and being in the shade are probably the most important elements to preventing heat stroke or heat illness. So we're going to talk about the risk factors of heat illness, prevention of it, how to respond, and then also supervisor guidelines. Some different ways that we want leadership to prevent this, because you are in a lot more control of the day-to-day. So OSHA's standard, it's a 1910 for the heat illness prevention. Applies to places that work outdoors, which is most of our work. Requirements, essentially we need to have training, which we're covering today. We need to provide water for our employees, or some sort of hydration. Even if they have to purchase it, it's fine as long as it's there for them. Access to shade, and then local procedures for heat illness prevention, which in our case is, we don't have too many days over 100 degrees, but it does happen. But even over 80 degrees, you can potentially get heat stroke, depending on a lot of those factors we went over earlier. So prior to work in warm weather, which is coming, we definitely want to give training. We want to talk about where you're going to definitely have issues, time of the day. We're going to be way out here, away from a store or anywhere to get material. We want to make sure we bring plenty of water to this job, etc. The importance of recognizing and then reporting signs and symptoms of heat stroke, like, hey man, I'm not feeling so good. Maybe I had a little bit too much last night. My body's still recovering. If that happens, it's easy to say, I don't want to be a wuss. I just want to work through it and, make it happen, get her done. Heat stroke is, the problem with heat stroke, it's a little bit like frostbite. Once you get it the first time, you are way more likely to get it again. So your body's weakened permanently from that sickness that you can get. So definitely want to make sure that you prevent it. You may be seen as, a wuss for a day, I guess, but you're definitely going to have the rest of your life to thank yourself. And then also emergency response procedures. What do we do if somebody does get heat stroke? How do we handle that? So obviously, weather conditions, humidity can also affect this. Lack of air movement, you get some wind, that's going to cool you down. Without wind, being stuffy, you can definitely experience heat illness a lot quicker. Sunshine, reflection, if you're working around a lot of metal outside, that can reflect off and essentially cause another heat source right there next to you. And then conductive heat, the ground, usually scoria and gravel are not going to reflect a lot of heat to us, but things like concrete will. So depending on, how much work you're doing in the summer, typically work longer hours when, it gets light at 5:30 and stays light till 11 p.m. You can make a lot of hay, while the sun is shining. But again, taking more breaks, especially during the hotter hours of the day, is extremely important. And depending on the type of PPE you're wearing, the thickness, the breathability, etc., this can all combine together to cause problems. So personal risk factors, I mentioned, alcohol consumption before, but being in poor physical condition can increase the likelihood of heat stroke. If you haven't really hit the gym in a while, or been behind the desk during COVID, now you're outside working a lot, you may not be able to work the same you did, as you did 2 years ago. Age, degree of acclimatization. We joke with a lot of Texans and Southerners who move up to North Dakota before their first winter. We're like, oh man, you have no idea, which is true. I mean, if you've not been up here during winter, you're about to work outside for 3-4 months. It's going to be some adjustment time necessary. Same thing if we go down south, or if we have a longer heat stretch, it's going to affect us too. We may not be acclimatized to it correctly. Definitely. Most importantly, water. If you're not hydrated, it's going to exacerbate and increase the likelihood of an heat illness exponentially. So making sure you have enough water. Certain medications can also dehydrate you. Alcohol and drugs obviously can dehydrate you. So make sure you're getting a lot of water and avoiding stuff and caffeine is another one. Caffeine can dehydrate you quickly. And if you do drink coffee, like me, quite a bit of coffee, just remember to, have a water back with all the coffee that you drink. So how the body handles heat, essentially, you do have a cooling mechanism and a heating mechanism that manages your body temperature. As internal temperature rises, your body's going to try to, kind of lower that, and it uses water for that purpose. It's a fantastic mechanism for cooling. So as your temperature rises, blood flow is going to increase to the skin, releasing sweat to the skin surface. That's trying to cool you off. It'll warm the water and then get rid of the water. So that's your body's method of doing it. So as you lose the water, you're also going to lose things that are in that water, electrolytes, salt, etc., which your body needs also to keep yourself cool. So when that happens enough and your body gets overwhelmed, essentially the mechanism that cools you down stops working entirely. So you can go from being just a little bit warm to extremely warm in an instant and sick. Essentially, you're going to have heat stroke or some other heat exhaustion or heat illness. So again, heat exhaustion leads up to that. That's why you want to catch it at that point and be like, man, I'm not feeling so good. I'm a little tired. I'm beat all of a sudden. I need to take a break, get in the shade, drink some water. Listen to yourself. Listen to your body. And supervisors out there, be supportive of this. Plan for it. Think about it. Be prepared. Have water and let guys take as many breaks as they need. So the cause, again, is total breakdown of the cooling system. Once sweating stops, we're in trouble. Mental confusion is going to happen, losing consciousness, getting foggy, saying weird stuff, almost like being drunk. Fainting typically occurs. Seizures and convulsions, as well as vomiting, are also signs and symptoms that we're heading into or have experienced heat stroke. So emergency response procedures, you definitely want to know what to do if this happens. So 911 is our easy answer, but there may be a quicker method if we know that's the case. You can transport someone with heat illness, but you definitely want to make sure you're keeping them cool, but not too cool. You don't want to take them from being heat stroke to minus 40 in the cab of your new Ford truck. It kind of needs to be a slower cooling method so it doesn't shock the system. So move the victim to a cool area, give a small cup of water if conscious and not nauseous, loosen and or remove clothing, fan and mist the person with water and apply a water-soaked towel. This is fantastic. Or ice pack wrapped in towel to head and an ice pack to armpits. Now, armpits are another area where our body releases a lot of heat. A lot of you probably know. And so cooling that area as well is extremely important. So getting them to a physician immediately is extremely important. So, if you're in the Watford area, Extreme MD, I think the Watford Clinic, really any hospital at this point, get them there, get them care. Prevention of heat illness, again, I can't mention it enough. Water. And if you're not sure you've had enough water, a lot of you have seen this around. The urine chart, you probably already know it, but the clearer the better. Drink as much water as you can. And now a lot of us know if you drink a lot of alcohol or caffeine, your urine will also be clear. But again, we definitely want to make sure there's a lot more water causing that than the dehydrating liquids. Access to shade is another OSHA requirement. Need to make sure people can take breaks and cool off from the sun. So supervisors, again, I've talked about this a little bit. I'm going to go a little bit more in depth here. You should know, hey, it's going to be 85 degrees here today or more. I need to make sure that my guys have shade today or that we plan out breaks. So if our customer wanted to get X amount done, well, we're going to need to take at least 4 or 5 breaks. We're not going to get that much done today. Communicate that ahead of time. Let everybody know so that we're not pushing guys to work harder than they need to, because heat exhaustion and stroke do happen. Not so often in North Dakota. I think we all kind of know our limits a little bit because we're not working around it so much. But in places like Texas, every year a couple people die from heat stroke in Texas. And it doesn't need to be that way. Taking breaks, having enough water, et cetera, will prevent that from happening. And the higher the humidity, the more breaks that we're going to need. So again, if there's something really strenuous to do, maybe don't do that from 11:30 to 1:30. Maybe put that off and do some lighter load work, and then earlier in the day or later in the day when it's cooler, maybe that's when we do our higher strenuous work. So kind of scheduling and working around that. Making sure that people are acclimatized to the weather. If we haven't really experienced this, and I wouldn't cry if we did, but if it just turned 100 degrees tomorrow for no reason, you may not want to work the same that you did when it was 40. So just as an example. So once again, 85, I mentioned a few times, is the magic number. 85 degrees Fahrenheit is where we really need to start taking precautions for people. Staff need to be reminded to drink plenty of water, take water breaks. If you're a supervisor, have a cooler in your truck or a case of water in your truck. We get a pallet delivered every spring, so I think we just got our pallet the other day. Just guys, throw a case in your truck and always have some water on you. Effective means for employees to contact the supervisor. Once again, following your emergency response procedures. And then you got new people out there who are trying to prove themselves and work really hard. Make sure you keep a close eye on them. So having written procedures, heat illness prevention guidance, essentially, hot work and hot weather work. Need to train everybody, which we're doing right now. Again, access to water and shade. I know I've said it 100 times. I'm going to try not to say it again, but those are the most important parts of heat illness prevention is water and shade. Monitor employees as supervisors. Kind of if you see them getting real sluggish and not really performing to what their typical standards, get them a break. Hey man, as a supervisor, you got to be watching for this. Respond to heat illnesses without delay. Take them seriously. Don't just be like, oh man, you're a wuss, you can't take it. Be like, no, this guy needs some water. Otherwise, this will be a recurring chronic problem for the rest of his life. And then obviously the training needs to be documented. So kind of wrapping it up, again, putting a lot of this on the supervisors because you're scheduling the work. You know how long it's going to take. You know who you have out there. Kind of responsible for their breaks and amount of work that you're expecting them to do. So as a supervisor, definitely pay attention. So understand the heat illness prevention, which we've done today. Understand their heat stress potential. You got a bunch of older guys on a crew for the day. Going to be 100 degrees out or 86 degrees out, and maybe not in fantastic shape due to COVID or other reasons. Maybe take it easy on them when it's hot outside. Give them a little bit more rest. Develop and train staff on the heat illness. What can happen, lack of sweating, extremely high temperature, etc. To recognize those signs and symptoms. Provide access to. I said I'm not going to say it again, so I'm just going to let you read it. There it is. Give you a little pause. Water and shade. All right, couldn't help myself. Plan and manage work activities according to reduce the risk of heat stress. Again, supervisors really making sure you're taking care of this and promptly respond to anything that comes up. All right, well, this month's a little bit shorter. I know the last couple months have been longer, so I appreciate your patience. Again, the quiz here is at the end. Please take that. We really appreciate you and hope you stay safe out there in the field. And actually, before we go, I do have one other element here, and that is anhydrous ammonia. You've seen these tankers around. It's summertime. As I mentioned, there's a lot of heat. These tires are a lot of times old on these trailers. They're not well taken care of. This is used as a fertilizing agent for soil, and it's extremely dangerous. If you see an accident with one of these tankers, stay far, far, far away and as upwind as possible. This is highly dangerous stuff. The DOT Emergency Response Guidebook recommends a minimum of an eighth of a mile distance from any sort of release with this chemical. So if you see it out there, make sure to stay away from it. If you're driving around it, be careful, give it plenty of room. These things are not to be trifled with. So again, summertime or springtime moving into summer, you're going to see a lot of these trailers running around, not always in the best shape, not always up to DOT standards. So just be careful around it. Know if you see a release or a leak, a gas coming out, and you will see the gas. It's not clear. You'll see it. It's pressurized liquefied petroleum gas or ammonia gas. It will cause some serious injuries and death. Essentially, a couple breaths from this, oxygen's displaced from your lungs. You can't breathe, and you will expire very quickly. So again, protect yourself. You see these driving around. That's our May safety moment. Everybody have a great month, and see you next one.